Hey guys, welcome to day 2 of these matrices that we are looking at. So this is the second half of 6-1, just in case if you weren't aware of that. This is the second half, so 6.1, day 2 is I think what we're calling it. Excuse my dog in the background. So we looked at Gaussian elimination yesterday, which in the matrix format was row echelon form, where you had 1, 1, 1, and then these were the zeros, and then you had basically anything after that, right? Just as long as you had it in that triangular format, these numbers were fine with whatever they were. Now you guys are going to look at reduced row echelon form, which is that. Reduced row echelon forms means that you are going to get everything except for these leading ones put down. Now, this is literally the same thing as solving a system of equations. Because, before, say, what was that problem we worked with yesterday? We had x minus y minus z, and then you had the y, and then you had the z equals 1, and then you got it with that. When you went through and substituted everything back in, you actually ended up with x, nothing for y, nothing for z. The answer, I think, was 7. And then you had y, nothing for z, and that was -1, and then z equals 1. This right here, because it was y equals, x equals, and z equals, that's identical to row reduced. So it's going to be a longer problem, but it's going to get you to your final answer. So I just wanted to bring that to your attention. You have reduced and the regular row echelon forms.